Hi, my name is Aidan Devlin, and this is my demo for the databases assignment. So first I'm going to start off with the Irwin diagram. We have one customer, and most of the information in the customer entity is just information on the customer. There is a one-to-many non-defining relationship to lighting system because one customer can have more than one lighting system. So the lighting system entity here has one primary key contract ID, and it has one employee working on it. Has one customer, as the relationship mentioned before, and there's a one-to-one non-defining relationship to customer payment, and a one-to-many defining relationship to stock allocated. And there is a one-to-one defining relationship to lighting specification. The reason for the one-to-many stock allocated is because a lot of stock can be allocated to one lighting system, whereas only one lighting specification can be given to one lighting system. Okay, so lighting specification, as mentioned before, is a one-to-one defining relationship with lighting system, and it just contains the price of the lighting system and the description of the lighting system itself. Also, in the lighting system entity, there is a return date that has, which is the date at which the customer is going to return to view the lighting system, or to view the designs for the lighting system. Next, we move on to stock. So stock has the stock code, which is the primary key, and most of the attributes within the entity are just describing the stock. So it's the description, the quantity, and the price of the stock. Then there is the relationships for stock are going to category. So stock category has from stock to category is a many to one non-defining relationship, because each stock falls within one category, whereas a lot of stock can fall into one category can have a lot of stock, can have many different types of stock within the category. Stock category has the category ID, which defines the category, and then the name of the category. It also has a foreign key to department ID, because the category of stock falls into one specific department. Now, department is a very small entity, just defines the department, and also has a foreign key to category, because each stock category falls within one department, and there can be many. It's a one-to-many relationship because there can be a lot of different categories within one department. So stock allocated. This is the stock that has been allocated to a single lighting system. There are foreign keys to stock code, which are primary keys, and the contract ID as well, because the contract ID is there's only one contract ID, and there's a certain specific amount of stock to that stock allocated entity. And then there's the allocated quantity, which is the amount of stock that's been allocated from the stock entity. Next we have employee. Employee doesn't have any defining relationships with anything, because an employee cannot define any of the other entities. There's the employee ID, which defines the employee. The foreign keys are to lighting system, because one employee can work on many lighting systems, so it's a one-to-many lighting system, one-to-many relationship. Stock order. One employee can make many different stock orders, although each stock order is only made by one employee, so it's one-to-many again. And department. The employee works within one department, but many employees can work within the same department, so the relationship from department to employee is one-to-many. Stock order. The stock order has the ID, the order ID, and has a foreign key to stock order item. Now, that's a one-to-many relationship because within one stock order there can be many items that are being ordered. It has a relationship with employee, as already mentioned, and the supplier payment. The supplier payment, again, there is a one-to-many non-defining relationship. One-to-many because within one stock order there can be different suppliers, and so forth. So therefore there has to be different payments within that order. So the supplier entity has the supplier ID, the name of the supplier, and the name of the supplier. The relationship is one-to-many for stock order because one supplier can only supply one. A supplier can only supply one. It could be involved in one order. Or an order can only be ordered from one particular supplier, or one supplier can have many different orders to the company. Stock order item has just the stock code and the order ID to define it, and then it's the quantity and the price of the stock that's being ordered. The relationship between stock and stock order item is one-to-many because there is one item of stock being ordered, and it can be ordered to there can be many different order items. Yeah, so supplier payment is a very small entity again. It just contains, so there's the payment number and the order ID, it's foreign key. As mentioned before, there's a one-to-many relationship between stock order and supplier payment. Customer payment has the payment number for the customer and the payment date and the customer and the payment amount. It's just information for the payment, and it is a one-to-one non-defining relationship between lighting system and customer payment. Okay, so I'll move on to the SQL now. This is my SQL document. First, I'll just run through the whole. I'll just quickly go through what each of it is. So first things first, just dropping all the tables at the start, tables that were created, then creating the tables. Pretty standard kind of stuff. Just name of the table, then the variables, and then how many characters for the variable, and then defining, and then not null for primary keys and null, they can be null for non-primary keys. And then the constraints afterwards. I actually forgot to name my constraints when I was making when I was writing the SQL. So they have the constraints that were given to it from the Irwin. So yeah, it's pretty much all pretty much copy and pasted throughout for the different tables. Some of them are a bit more complicated, as they have more columns. Stock is one of them, where it has 1, 2, 3, 4, 5 different columns, and then primary keys as well. So it's all the same kind of stuff really. So I'll scroll through that and go to the populating the tables. Now for the tables, I commented the name of the table and then the attributes within the table, or the columns within the table, the names of them, more for my own sake, so while I was writing them. And then the insert into, there's no need to have brackets after the department which name the columns, because I'm populating the entire row. I'm not just populating certain types of, or certain parts of the column, or certain columns within the table. So yeah, just pretty standard, just inverted or quotation marks for the varchar types, and then later on we have here in stock 10 different items, and there's 5 different columns within each one. So the IDs, and then a description, and then no need to put in quotation marks for the integers. They're just numbers, they're values. And then so let's go through to one that has there's one that has dates. So there's the dates being put into customer payment in the payment date. Yeah, so all pretty kind of all the same really. And then stock allocated was a larger table, because there is more than one item of stock allocated to each job, and I took care to make sure that they were all the prices matched up. Like, for example, the amount that the customer pays is more than the amount that the job costs in terms of stock, because the customer is paying for the design of the thing as well, and the amount of stock that is used matches up with the amount that is charged, or the amount that it costs the company. And then I have a commit statement finishing all that. So what I'll do is I'll run the whole thing, and then I'll start getting into the queries. So here's that's the whole thing run there. Up to the top here, so drops all the tables there, and then creates all the tables, and then inserts all the rows, and scrolling through it, scrolling down, scroll, and then that's it, committed. And then I'll go through these now in just a moment. I'll get rid of that, and then go through them line by line. Okay, so the first requirement was to have a single row function. I used the uppercase function. Oh, sugar. Sorry. So I use the uppercase function, which just returns all of the employee names, all in uppercase. Next, I did there was an aggregate function, so I got the average. I got the average amount paid to all of the suppliers, so how much the company is paying out on average per order. It returns the one average supply pay amount 1,203. Next was a inner join between two tables. So I selected the customer table and the lighting system table, and I wanted to get the customer name and the date in which that customer will be returning to view the table, to view the design. So this is the list of customer names here on the left, and the date at which they're coming back to review the design. Next was an inner join on three tables, and again it was similar to the last one. Gets the customer name and the date they will be returning, and it also returns or displays from the lighting specification the description of the lighting system that they'll be coming back to look at. So they have your name, date, and what the customer has asked. Next we have the left outer join. So this one I wanted to return all of the employees that are currently not working on a contract. So it joins employee and lighting system, and so basically whatever employee isn't on one of these on one of the lighting systems, it doesn't get returned, or gets returned. Sorry. So you have 4 employees that are currently not assigned to a lighting system. Next we have the right outer join, and this is similar. It's basically the opposite to what I did for the previous one, which was listing all of the employees that are currently working on a contract. So it repeats some of the employees because they're working on multiple contracts, or working multiple lighting systems. Next I have the update the table one, which is, so it sets the employee ID. Where the employee ID is 1, it changes his name to Kevin is great. So I play that one, and it updates the table. Yeah, one row updated. Next was the adding a column. So what I did was add the column start date to the employee table. So I'll run that, and then if you look at the employee table over here, there's start date here. Next was add a value constraint. So what I did was I made sure that in stock order item the stock or the quantity could not be 0. It had to be 1 or greater, so to make sure that they wouldn't accidentally order no stock from a supplier. So yep, table, there you go, stock order item altered. Next was to modify a column. So I changed the supplier payment, modified it to so the numbers, so you could enter a larger number to supplier payment, because there could be quite large numbers coming in or being paid out to suppliers if there are large orders. So that table, that's been altered. Next is drop a column. So from the employee table earlier where I created a column, I'm now going to drop that same column. So employee altered. So hold on a second. Drop column start date. Play that one. Yeah. Oh, I got an error because it already ran the script earlier. Okay. So next one, I have the drop the constraint, which is the constraint I made earlier, which was to update or to give the check, make sure that the order was not null. So run that one there, and stock order item altered. And yeah, that's it. Thanks very much.